morning, and I do want to apologize for the technical difficulties that we experienced yesterday. The GoToMeeting, GoToWebinar Citrix system that we use had a server issue at the during the hour that we were scheduled yesterday, and so unfortunately I was unable to get online to notify all of you what was going on, and I couldn't get through to tech support either because all their clients were calling with the same issue. So for those of you that did hang on for a long period of time, I certainly do apologize, and we're very glad that Reg was able to reschedule this for this morning. So with that, I want to introduce Reg Hunter, who is a productivity improvement consultant currently working with Next Generation Productivity Solutions, the Deluzio Group, and PAM Projects Panalpina. Previously, Mr. Hunter worked for URS Corporation, Applied Materials, Trackcore Aerospace, and Honeywell in the areas of productivity improvement, optimization, systems engineering, advanced technology development, project management, quality management, strategic planning, and business development. Reg has used his expertise to co-develop a comprehensive job site materials management solution along with supporting situation assessments, tool sets that identify and drive optimal productivity improvement solutions. He's a change agent and driving force in creating value through innovation and has been granted 23 patents with over 10 patents pending. He holds an electrical engineering degree and an MBA from the University of Texas at Austin. He's a contributing author to FIATech. He's currently working on our RFID for Materials Management and Productivity Improvement book. And he is also collaborating with HAL Inc., which is a leading supply chain support software provider, and PAN Projects, a global logistics service provider, along with other EPCs and owners. So with that, I want to thank you again, Reg, apologizing again for yesterday, and let's get started.
Great. Thank you, Nicole. It's unusual for me to do presentations, but just staring at a screen, I'm used to having some sort of feedback, so bear with me. I'll try not to talk too fast and stay very close to being on point, but please make sure to provide questions to Nicole, and I'll be glad to elaborate and answer anything you desire. I probably should give you a little bit of background. We evolved our approach to productivity improvement sort of in a different way. We really weren't oriented to promoting a technology and then trying to force fit it into some sort of application. But because of my background, I've always been involved in projects that had a problem that had to be resolved, and I think it's a little bit challenging because of my combination background, both the MBA and the double E. That from a technology standpoint, which is really interesting, it doesn't really matter much unless it really solves a problem, which is obviously the MBA dimension. So these slides relate to basically highlight a perspective that you guys, some of you folks may have not considered. And as you know, in the construction industry, there's a variety of different perspectives, and there seems to always be someone in the group that says, yeah, that's interesting, but my case is different, and that situation really isn't what I do, so it really doesn't apply. And invariably over, the last 4 years, I've been asked, well, what is, how much does it cost me to do productivity improvement? What's my ROI? And a lot of times it causes me to pause, just like now, because the problem I have is that the next question I usually ask is, well, how much do you spend in inefficiency, and how do you go about recognizing that? Because to be able to talk about ROI, you have to know what it is that you're addressing with respect to any kind of productivity improvement. And so I kind of push back that direction, because for me to be able to give them an answer is very difficult without that knowledge. And invariably, a lot of times, even with large companies, they don't seem to have a good handle on what that really means, on what their expenses are and what their avoidable costs are. So what this presentation relates to is how to think about your processes and convert them into some sort of systemic and non-systemic types of inefficiencies that can be overcome through productivity improvement. Okay. So to kind of start from the top here, what I kind of think makes the most sense with respect to existing capital projects is the projects tend to be very aware of how much is being spent, how big is the labor pool, how well are we doing with respect to schedule, and dealing with issues. And so I call that what was going on, because invariably you don't have real-time awareness of situations that could end up costing you money, but you may find out about that in about a week or something like that. And so there's a high reliance on the labor pool in order to perform their jobs effectively. And the problem with that is that under stress, like having multiple vehicles pulling up to the construction site, for example, it's very difficult to maintain processes in order to minimize the potential for excursions and problems. So I guess I would contend that in a lot of ways the existing processes tend to be fragile when they're challenged by weather and multiple vehicles and so on. They tend to be very dependent upon the labor force, and inherently they tend to be inefficiency. And I'll give you some examples of that. That coupled with the delayed and inaccurate monitoring kind of pushes, and I've seen it on a number of different, working with a number of different EPCs and actually owners, that it tends to evolve into a fighter-fighter type mentality where, you know, we've got to deal with this, got to deal with that, and they just move from one fire to the other and try to just keep things going. And then the tendency to deal with all this stuff is, you know, authorize overtime, work harder, hire more people, and things like that. So what this presentation relates to is how do you move from that framework of your circumstances into what I'm calling a situation awareness, which really gives you the what is going on perspective, which gives you the end-to-end visibility, predictability, and control I think that everyone would like to have. By the way, situation awareness, and it's also called situational awareness, was a term that came out of the Vietnam War, and it was actually used initially, I think, for fighter pilots. And what was happening is that they were trying to provide the fighter pilots with as much accurate, real-time information for their decision-making so that they could actually, you know, perform their jobs. But equally important is obviously not get shot down by a missile. So if you can achieve situation awareness, what you can really do is you can have knowledge of what's going on in near real time, and you have a system that's inherently more agile, robust, lean, and efficient. Okay, and to do that, though, you have to have some degree of automation, and you have actionable information that's coming out of the automated systems that allows you to make informed real-time decisions. Okay, for example, if you had an excursion, let's say you had a damaged pipe spool, if you could detect that as early as possible and have your suppliers be aware of it and all the parties that are affected by the damaged materials virtually automatically and virtually instantly, then you can actually detect the excursion and coordinate a recovery before it becomes substantial against your overall schedule. With that, you're able to achieve proactive decision-making, and it tends to be a lot easier to make your system work better.
Say, Reg.
Yes?
I've had about 12 people email me saying they're really having a hard time hearing you because you're talking softly. If you could speak up, that would be helpful.
Okay, I'll move the microphone a little bit better. Is that better?
Better, thank you.
Okay, so I'm sorry about that. That was more of a preamble anyway. I've been in meetings with some owners down in Houston, and one of the things they point to is they say even though we have RFPs that talk about what are you going to do from a productivity standpoint, they have difficulty bounding proposals and recognizing whether or not, for example, an EPC has essentially provided a productivity improvement approach. And so they're trying to come up with ways to establish metrics in order to determine whether or not one potential EPC is better than another based on part of the criteria, which would be productivity improvement type strategies. I think as you guys know better than me, there's a tendency toward having a migration away from fixed pricing to, a migration to fixed pricing, which makes the emphasis on trying to drive down costs and realize higher levels of efficiency much more important. A story from probably, 3 years ago, I was talking to an EPC, and I said, look, currently you have 14 folks working in your laydown yard, and with these technologies, you can essentially get it down to below 10, and I showed him why. And he said, well, look, I don't really understand, Reg, why I would want to do that, because my compensation is based on actual costs, and so for me to drop my head count down from 14 to 10 actually means I lose money, which, it's true. Okay. So anyway, what the discussion topics I'm going to cover today is the concept of process streamlining, systemic and non-systemic inefficiencies, and how do you value those, and then how do you go about putting them in an organized way that allows you to have a productivity improvement plan, and then I'll describe a total productivity improvement system. Nicole, are you able to hear me okay now?
I was on mute, but yes, it's much better. Thank you.
Okay, thanks. So this, don't make a mistake with this. Process streamlining isn't the same as conducting a site survey when you're evaluating a technology as part of a pilot test. All this presentation relates to a system. It doesn't relate to a technology, although technologies are used to allow you to realize a system. Okay. What process streamlining relates to is if you look at the systemic and non-systemic inefficiencies of your process and you think of it as a stream, there's different sources of turbulence to all the different types of flows, and there's three different types of flows essentially. One's information, obviously one's workflow, and material flows. And anytime something happens, any kind of disturbance that happens, it causes schedule to be stretched out, it causes cost to be incurred, it causes additional resources to be reallocated, which in turn kind of has a ripple effect where other activities have to be put on hold or slowed down in order to support dealing with stuff. For example, when you have situations when you can't find a specific piece of material in the laydown yard, like a pipe spool, it's not unusual to hear stories about multiple craft folks out looking for materials, and it may take 2 or 3 days to find that. And so there's that cost, but there's also the cost of delaying potential deliveries of materials to the actual construction site itself. So process streamlining, which is discussed in the book, by the way, is a methodology that you can go through in order to identify these sources of turbulence. And the idea is that you can drive yourself toward realizing situation awareness so that you can essentially get the project done quicker with less cost and less risk. Okay. One of the things that I guess that is a little different, we don't really draw a distinction between the supply chain, the point of origin for materials, and the actual construction site. And in a way, to me, what it really matters is that you have material that's emerging anywhere in the world, migrating through this huge labyrinth of handling processes through logistics services providers, and then ultimately getting delivered to the construction site and placed in the construction site, and then being consumed on an as-needed basis during the build. Okay. And when I first started looking at trying to come up with this ROI discussion, and this was probably 4 years ago, I started looking at what is the probability of having a lost spool, or what is the probability of all these different things. And from a probabilistic standpoint, you certainly can express what the vulnerabilities are from a cost and schedule delay and things like that. But it's kind of abstract because it uses decision theory. So I started thinking, well, look, what if you don't worry about these disruptions like lost spools and stuff? What if you just don't worry about those at all? What if you think about things like what is the inherent systemic inefficiency associated with performing a task? Okay, and I'll give you an example of that. But if you can make an argument for productivity improvements just using that criteria, which is essentially these predictable costs occurring, which is what you see on your slide here in red, it's consistently occurring anytime you do a task. The costs are predictable, and if you solve those problems, you indirectly get benefits against the other types of inefficiencies, which are the disruptions and non-systemic. So you get away from having to think about the probabilistic aspects of trying to determine cost and benefits of using technologies, and you just deal with how do you streamline the existing process to make it better. And you use that as the basis for making an argument for productivity improvement.
Reg, I've still got a few folks having problems hearing. It seems like you're moving away during the presentation. So.
Okay, I'll hold it even closer.
All right, thank you.
I'm sorry. Is that any better? Okay. So there was a lot of studies that were conducted by CII and FIATEC and member companies that were really quite impressive, and they tended to seem to be these little flashes of compelling information, but it seemed like, at least from my perspective, that there is difficulty in having, in converting that into something that's actionable at the construction site. And it comes back to what I said before, is that the perception is that it's not, hang on, let me try to turn this volume up, maybe that'll help. The perception is that it may not be applicable to me. And so what I'm going to show you here is an example of a systemic inefficiency, and it relates to a study that was done with Fiatech and KBR that was associated with how much more quickly can you locate materials like pipe spools in a laydown yard. And in this study, they showed that if you use grids, it took on order of about 6.7 minutes to find the pipe spools, and if you went and looked for the materials and you used GPS to go find it, that 6.7 minutes dropped down to 0.92 minutes. Okay, so this was a single laydown yard. Okay, so when you talk to people about that, they say, well, you know, I've got 7 laydown yards and it's much bigger than this, and the time it takes to get to the materials is much longer. So it doesn't really apply. But if you think about it, what this study really shows you is that the difference in efficiency with respect to GPS per time you go to look for the pipe spool or any other material for that matter is about 5.8 seconds. Excuse me, 5.8 minutes. Okay. So, and you can assume that that 9.92 minutes really represents the time it takes to travel, and that's a kind of a constant, and it's dependent upon the geometry of your construction site. So, what we're really saying is that every time you go and look for a piece of material, you potentially will get there 5.8 minutes sooner than you would be with GPS than you would be by simply using grids. Okay, and you add on top of that is what is the number of times that you have to go find materials. You know, clearly when you place the material there, you may go inspect it, you may do audits to make sure that you have all the material available to go support the fabrication. And on top of that, it isn't like one individual that goes out. You have an aggregated labor pool, which may be 3 or 4 craft folks with like teamsters, riggers, pipe fitters, union folks. And you have to consider their whole cost as well. So what I'm saying is that any material you have in your construction site in this example has to be located at least 3.5 times. In this example, it varies. And the aggregated labor pool associated with those tasks is on the order of $300 an hour. So I'm going to show you on the next slide some examples of a small project and a large project where the implications of inefficiency, which is systemic, is $1.5 million for 15,000 locate tasks and $12 million for a very large project. I'm sorry, are you having any luck at all with hearing what I'm saying?
You know, when you start out really strong and then it just gets a lot lighter. So if you can just kind of stay as close as you can and talk as loud as you can on the microphone, I think that'll help. A lot of people have speakerphones and are in rooms with other colleagues, and so they're having trouble hearing.
Okay, well, I'm going to hold it really close. You might get breath noise. Okay, so this slide is sometimes called a nomograph, and it's really a nice tool to allow anybody to think about their particular application and come up with a number with what I just described. Okay, and so what we're in this case across the bottom, which is the x-axis, you can look at this as the number of times throughout your project you envision that you'll need to go find material in a laydown yard. Okay. And then you also have to consider, let's say if there's 15,000 pipe spools, you have to consider that you have to go find it on the average, and you can pick a number, but let's say 3.5 times. So you end up having to find materials at your construction site in laydown yards about 52,000 times. Okay. And then you can slide up and look at the intersection. So if your aggregated labor rate is $300 an hour, which is what's shown here, you go up to that intersection and you go to the left-hand side. That represents $1.5 million in inefficiency. Okay, and so you can move around anywhere you want in this curve depending on your circumstances and the questions you want to ask, because obviously labor rate changes. I know that in Australia the labor rate's about $200 an hour. This is whole labor rate, not just take-home pay for the worker. All right. So another way to look at the systemic inefficiency is that everything you do, there's an unavoidable cost component, which is you need the crew to go out and get the materials. You can't really do anything about that, but you can help them find the materials more quickly. Okay, and what you see in red is the feature associated with performing locating activities that are systematically inefficient, and those are the features that you hope to recover and reduce. Okay, and then you have the unavoidable costs, which is what you see in white. All right, so as you know, the amount of activities and labor tends to be forced forward to the left-hand side, so it's not a normal bell-shaped curve. So in the first year, you have the majority of activities being performed in this example. So let's say 70% of the activities associated with moving pipe spools is completed in the first year. Okay. Another way to look at that same data is to think about it as an aggregated figure. Okay, so as you progress out through your project, you have more and more systematic inefficiencies, costs that overarch and lay on top of the unavoidable costs. Okay, and so that's really what you have to think about from a productivity improvement standpoint of trying to reduce. So in a sense, no matter what you do, you have in this example, you have $1.5 million sitting on the table when you're done with this project, just with respect to locating materials in laydown yards for a variety of reasons, doing PMs, doing inspections, all those types of things. You have $1.5 million sitting on the table. So when someone asks, what would it cost me to implement productivity improvements like handhelds with GPS and RFID readers and and barcode readers, you say, well, it's costing you $1.5 million right now to not do it. Okay, so when you think about these technologies, and they may cost, I don't know, $80,000, it really is eclipsed by this other number. Okay, so to roll those numbers up into something that's in a table form, what I'm showing you here is the equations, and again, this is in the productivity improvement book, but I'm showing you that how the numbers come about. Like you have the locating time, which is 6 minutes, which is, you can pick any number you want. You have the number of pipe spools, okay, and you have the number of times that you go locate the pipe spools. You have the aggregated labor hour rate, and then you end up with, in the small project, you have about 5,000 hours of labor that has to be paid, and you end up having the inefficiency cost of $1.5 million, like I told you. In a larger project, you have an inefficiency cost of $12 million. Okay, so this is trying to converge on an ROI. Okay, so this is the kind of thing. And by the way, keep in mind, I've described just one activity, which is a locate activity. So talking about an ROI, if you implement some technology, it benefits multiple things as well as your non-systemic productivity challenges. But if you only focus on this locate and you do an ROI calculation on that, that's what's shown here. Okay, so you start off with a duration of 2 years. You have the two scenarios of 1.5 million and 12 million. And you say, well, look, there's no way in heck that I can recover 1.5 million or 12 million. So let's assume that you can, the potential avoidance is only 25%, and you multiply those together and you get the numbers like 375K for the small project and 3 million for the larger project. And again, if you recall, I pointed out that in the first year, a lot of the activity takes place, like 70% of it. So in the first year, you potentially have $263,000 worth of avoidable costs that you can potentially achieve through productivity improvement. In the case of the large projects, it's 2.1 million. Okay, so the monthly savings that you end up with is 22K per month in the small project as well, and then 175K in a large project. Okay, if you assume, and there's different numbers, but if you assume that a GPS with RFID upgrade runs about 67K, in a larger project it's 250K. And by the way, there's some stuff that I did for some Canadian oil companies that the largest number I've ever seen was 200K, but it was a huge project. But anyway, the payback period is 3 months in the case of a small project and 2 months in the case of a large project. So the return on investment for the first year is 393% and 480. So you can see why I paused in the very beginning when I was talking, that when someone asked me, well, what is it going to cost me to go deploy a productivity improvement? And I pointed out that we need to make sure we understand what it is we're talking about here, because you already have a lot of inefficiencies that are going to be offset. And so you can see how these numbers are so large that even if I'm wrong by almost an order of magnitude, or even an order of magnitude, it's still very compelling to seriously consider providing a total system productivity improvement plan and implementing things in a systematic way. Okay? So the bottom line is, in a large project with respect to locating, you save 2.8 million. So back to the original slide here. If you go from project awareness, which I talked about initially, and you think about the situation awareness, what you really need to do is have some method that you go through in order to drive you drive you in that direction. I mean, clearly you can come in and deploy an RFID thing, and you can deploy active RFID, and you can play with stuff, and at the end of the day, it's kind of interesting, but it really isn't part of the mainstream of how do you want to go approach this from a system standpoint. What you really, to me, what really makes the most sense is that you say, look, I'm not going to do any more pilot projects for a while. What I really want to do is come up with a capital project productivity improvement plan. And what it does is it delineates all of the inefficiencies, and you figure that out using process streamlining. It ensures you make sure you identify all the stakeholders and that you have consensus across the board, because if you don't, and someone like, let's say, your suppliers aren't on board with what they need to be doing, then it doesn't do you any good. You won't be able to realize a productivity improvement. Then you don't want to come in and just throw money at it. What you really want to do is you want to understand what are the inefficiencies, what is their characteristics, and how much would it cost you to overcome those inefficiencies. And that lets you essentially define an optimal system productivity improvement along with costs. And so instead of just turning a switch on and saying we're going to go do this, what you really want to do is use the productivity improvement plan to lay out what prioritize and incrementally deploy things. So for example, you may want to only deploy handhelds with optical barcode readers and RFID and GPS, because by the pipe school example I just gave you, because they give you significant benefit. But you shouldn't do that until after you do the plan, because there may be other more compelling attributes in your process where you can get a much better benefit with lower cost. Okay. On top of all of that, the productivity improvement plan allows you to establish what are the performance monitoring methods and metrics that allow you to have the actionable information that I talked about already. Okay, so the productivity improvement plan objectives will lay out and will increase competitiveness. It defines all the aspects of the productivity improvement campaign. It provides the foundation for a company to approach multiple projects in the future. It allows you to do lessons learned and get better and better at productivity improvement rather than have these isolated events. It allows you to link all those things together. It allows you to have the basis for establishing and defending proposals on fixed price contracts. It allows upper management to communicate expectations and motivate things to the company, throughout the company, and also allows you to prioritize pilot and proof of concept tests, because you don't want to really go play with the technology in order to, if it isn't really helping you from an overall productivity improvement planning standpoint. Hopefully that makes sense. Okay, so what I'm going to talk about now is that when you do this, when you do the process streamlining, you understand sources of turbulence and you understand the costs that are created by those sources of turbulence and how all those interrelated activities are affected by certain common elements. What you can do is you can actually start seeing things emerge, like there's methods and elements associated with existing systems that actually prevent you from realizing productivity improvements. And for example, identification, there's multiple identifiers that are created for the materials throughout the process, and there's also multiple pieces of information in different databases that are associated with tracking the material that have to be entered manually and things like that that is currently taking place that prevents you from realizing productivity improvements. Obviously, information management and accessibility, if you don't know something's going on, you really can't react to it, and coordination of material movement and monitoring that the transaction have taken place and things like that. Those are the kind of elements that we've seen come up over and over again that are essentially common throughout most of the activities that actually contribute in a large part to preventing realization of productivity improvement. Okay? So ideally, and come back to the second slide, what you really want is total visibility of the materials from point of origin all the way to point of consumption at the construction site. You want to have someone be held accountable and responsible for the materials anywhere throughout the entire supply chain and at the construction site, so that this accountability causes them to be more in tune with making sure the problem is identified as quickly as possible and mitigated as much as possible. Obviously, if you have this kind of information, it increases predictability. So you know the materials has been damaged and been delayed. Everyone who has a vested interest and stakeholders in the whole process know that. Clearly, especially from a nuclear power standpoint, you want to have traceability, pedigree, and chain of custody awareness of all the materials that you're using and managing through the supply chain and at the construction site. If you do that, it sounds pretty intimidating, but if you do that, what you really do is you have the chance now to have a system-level productivity improvement solution. So having said all that, I mean, this is one of my favorite phrases, although no one seems to be able to relate to it. This really isn't this isn't a theoretical thing. It's really real, okay? And it's not that far away, and I'll show you why. So to kind of visualize it, here's an example of a productivity improvement enabling solution. Okay, hopefully this slide's fairly clear, but material, as everyone knows, can essentially emerge anywhere globally. It can be provided by the owner of the construction project. It can be provided from other projects. It can be fed directly into the supply chain. It can be emerged from the suppliers way upstream. And so the material basically is converging at the construction site from a myriad of sources under a myriad of circumstances by different parties. And there's different estimates, like for nuclear power plants, there could be over 3,000 suppliers, for example, globally. And so what this system shows you is that if you had awareness of all the materials and you were able to identify it in a systematic way at the point of, as early in the point of origin as possible, and you were able to track it in the database all the way through the supply chain up to and into the construction site, then you would be able to essentially overcome the things I just described. Okay. On the right-hand side of the figure, which is the enhanced site management systems and engineering and the EPC systems, this is kind of a blurry thing because some of the larger companies have very well-established systems that they use at the construction site. And so in those cases, the SMMS system really doesn't have much of a play. But in other cases, SMMS system would actually be used to would be very helpful for the smaller companies or companies that don't have the capabilities that they want. In the figure, what you see also is the use of GPS as well as RFID, and you can see that RFIDs are always issued at the point of origin in addition to a data matrix label, and GPS is used, for example, at the supply chain in the marshaling area to manage the materials that are being packaged for shipment, and also monitor and manage the materials as they're being loaded onto the ships. And they're also as materials inducted at the construction site, it's monitored with RFID, optical barcode, and GPS as well. And then obviously at the construction site, both RFID, GPS, and optical barcode is being used. Okay. So having said all that, one of the frustrating things that has happened is that invariably when we have had conversations with EPCs about running pilots of a system like this, what happens is that they're very driven toward meeting their deliverables to their customer. And so it's very difficult for them to put on the brakes or redirect their resources, because they're fighting fires, redirect their resources to think about things like this. It would make sense because if, invariably what will happen is they'll say, well, we're pretty much done with the project, or I need some schedule relief, or I need some additional funding, and I'd like to have some meetings, and I'd like to have consensus. And there's all these perfectly reasonable concerns that the EPC has at the construction site that prevents them from willingly embracing a productivity improvement. And so that's just a state of nature. There's nothing we can really do about that. And so the way we're approaching it is that we've decided that, well, it makes a lot more sense for us just to come at it this way. And by the way, at the FIATech conference at the end of March, we have an exhibit. I think I know there's going to be a workshop on Monday the 29th that any of you are welcome to participate in or give us feedback on what you'd like to see discussed. And then there's also going to be a brief presentation during the conference. The system is called Global Material Management Solutions. Obviously, this is our perspective. You have your own perspective of how you want to do things. So I'm not trying to sell you on this idea. I'm just trying to explain it to you. The only way that we could figure out that makes sense to come at this total system solution is to bring in the big players. And so PAN Projects is a global leader in logistics services and handling specific, for the most part, material related to construction at a global level. Very big fleet of ships and aircrafts and things like that. HAL Inc. is a software, essentially a database material management software provider that's used by a number of 3PLs. And then there's NGPS, which is related to work that I've done in the past at multiple companies. And what's happening is that we're converging all of our skills and knowledge and understanding of systems into what we're calling the Global Material Management Systems solution. That's pretty interesting, but it really isn't compelling until you think about, well, the GIM system really needs to have inputs like use cases, and like, well, how do you know when you have exceptions, and how do I have this kind of visibility in all these different scenarios? I'd like to see this as part of what's going on with GIMS to make sure I really understand it. It really is solving my problem. Same goes for EPCs. How do I know that? How am I aware of materials in reverse logistics going back and it's arrived and things like that and something wasn't lost? And then clearly from a fabricator standpoint and things like that, we need inputs from them. So back to, I talked briefly about the laydown yard and accessibility for pilots and things, and the way we're dealing with that is actually it's within sight of the airport in Houston. There's a PAN Projects facility which actually moves exactly the same construction materials that's used at a construction site. What's nice about this facility is first off, it's neutral, so EPCs aren't running it, so there's no reluctance on the part of one EPC to allow some other EPC to come and see the system run, but it allows us to essentially demonstrate this global end-to-end system solution to productivity improvement and also track and move materials in a way that would be consistent with how the materials are being moved in marshaling areas for the 3PLs as well as at the construction site. What's also nice about this is it's an ongoing operation, so in addition to standing up and challenging our GIM system, we actually have the opportunity now to perform ongoing technology evaluations and conduct training, do demonstrations, and perform validation testing. So we aren't really having to confront a construction site in order to realize the productivity improvements. What we're really doing is we're creating a pseudo-construction site with all the materials and activities and things like that that would be related to a construction site in an environment that allows us to be less disruptive to the construction schedule and costs and things like that. Hopefully that makes sense. In the upper left-hand corner of the figure, you see an example of a tag that's issued by our system at the point of origin, whether or not it's at the supplier or anywhere along the supply chain, with the unique identifier and the RFID tag. And there's a variety of different types of tags. This is just an example. Okay. So I touched briefly on this already, but it's really important to us to have something that's within reach. Okay, and so by using PAN Projects and HAL Inc., and already more than 50% of the materials that's being handled globally, the data that's associated with that material is already in the HAL Inc.'s database, and the access to those materials and those suppliers and those transportation mechanisms is already being done by PAN Projects. So you can see from a connect-the-dots standpoint that we have the databases, the data management systems, the vendor portals, as well as the accessibility at a global level to the materials and the construction site. So hopefully that makes sense. Okay, just real quick, a couple more slides, we're almost done. I mentioned earlier that a lot of the larger EPCs have very sophisticated and comprehensive material management systems, material management and control systems at the construction site. In cases where they don't, we also have a system that we use, which actually is a system that we'll probably be using at the intermediate marshaling areas in the supply chain area, where we can essentially assign transaction activities, verify the transactions, perform monitoring materials as they move at the construction site and at the marshaling areas. And obviously this system has to interface with the EPC systems and the data management system and other legacy systems. This is an interesting slide. I mean, it shows we tend to not like to think about a solution that requires a lot of infrastructure because, first off, usually a construction site is temporary. It may last 3 years, 2 to 3 years, and then it's gone. So you don't really want to go out in the jungles or in the in the back lots of these areas and try to set up a bunch of active RFID readers and a bunch of communication networks and things like that. Because first off, they probably won't survive. Getting power to them will be cumbersome. And so our approach tends to almost always be related to if I program a bunch of, if I assign a bunch of tasks, download it into a handheld, and like hand it to a pipe fitter, and he has a certain number of tasks he has to go perform, then he takes the handheld and goes and does that, and then the data is uploaded after that. Obviously, there's always exceptions to what I just described. This is an example of using 1-watt RFID readers where you essentially can get close to the materials and use the RFID reader in the sniffer mode to help you find it more quickly. And even though you're in a grid and you know the GPS, which is in 12 feet, you can actually use RFID to help you find it that much more quickly. And also you can use it to conduct audits of what you've installed. We use active tags. We have active tags in systems we've deployed in Kuwait. There's a variety of capabilities that are in it, which is interesting in a way from a construction standpoint, because you may have a container where you're concerned about insulation staying dry, so you'd have an active RFID tag with a liquid sensor in it, and it's continually being monitored by a reader. And we can read these types of tags at a distance of over 400 feet. As you see on the top, there's a variety of different types of capabilities, and which one you pick is related to what your needs are. So with respect to that, you could envision a scenario where you have RFID readers that read these active tags as you move down the roadways. You can also have proximity readers that maintain awareness of what's at your certain areas of the construction site, sensitive materials, critical materials, expensive materials, and things like that. And so you have this information streaming back into your database, which helps you achieve the situation awareness. So hopefully some of you could hear what I was saying. I apologize for the signal not being that good, but for follow-up information at the FIATech conference on March 29th and 31st through the 31st, there's a pre-conference workshop the morning of the 29th, and it's called Total System Approach to Productivity Improvement Planning and Implementation. If you're interested in that, please go to the FIATech website and look into it. If you also want to send me an email telling me the kinds of elements that you'd be interested in including in those discussions, would be glad to address those. There's an exhibit that's going to be at the show, and then there's also going to be a Jim's presentation. By the 30th, we're deploying our system right now in Houston, literally right now. So we'll have a lot of information in a couple more weeks about how that's going. And by the way, if you're interested in getting involved and understanding more about that, please just send me an email or give me a call. There's a book. I'm not real sure when it's coming out. It's been turned over to the designer. It discusses a lot of what I just described to you, plus it discusses a lot more about RFID. I think it's probably due for publication at the end of March or in April, and then my contact information is provided below. So that's it. Again, I'm sorry if you had trouble hearing me. Are there any questions?
Sorry, I was on mute. Someone wants to know if you could explain training, mislabeling, and damaged labels.
Yeah, well, one of the problems we ran into was if in our system, what we're going to do is be able to issue multiple labels. Okay, and so if you have parent-child, so let's say on your purchase order you have a line item for metal building. Okay, well there could be 4,000 items in that metal building, right? And so what we really want to do is as soon as the material is inducted into the supply chain and associated with a certain project, what you'll see is the parent-child relationship. It's a lot like manifesting and kitting that goes on in the supply chain on top of that. So one of the things that became real clear to us is that when we program these globally unique identifiers, we need to be able to issue the globally unique identifiers in RFID, write that information directly into multiple RFID tags. So even if you have a pallet or a skid, you may have essentially the same tag label on 3 or 4 sides of the skid because it's so large, but it still has the same unique identifier. And so that does a couple things. It helps you deal with the potential for damaged materials where a label may be torn off because there's a redundancy going on there, and also it helps you make sure that you have accessibility to the marking, whatever side you're on. With respect to training, for us to come into a construction site and say, you need to stop what you're doing, and we need to show everyone how to go do this stuff, and we need to all these things. What our vision is that, well, you come down to Houston, you send your folks to Houston for a couple of days. They can get some training and also do a walkthrough at the facility at Panalpina's facility in Houston, and you really aren't exposing the construction process to that kind of disruption. I don't know if that answered the question or not.
Thank you. Another question. Someone wants to know if you know of any projects that considered the value of RFID in the use of durable safety equipment.
No, I don't, and that's a real. It's making me smile because that's kind of been an interesting discussion, because if you want, for example, if you look back at some of those earlier slides, if you want to track, if you have an event like an emergency event, or if you have an exercise that you're going through and you want to see how quickly your security system responds or EMS responds, inherently, once you have the infrastructure up, especially with active RFID, you actually know how long it took the emergency vehicles to get to where they're going, and you actually know how long it took for the security guard to make his rounds at the facility, and that it took place, and that he had his night vision goggles and rifles and things like that as well. The only thing with respect to safety the reason I was smiling is that if you get real creative about it, you can come up with scenarios where you may have an RFID mounted on the goggles associated with a grinding station, for example, and you have an RFID reader at the grinding station oriented with a very limited field of view, so that you can verify that the operator has the goggles. And you may not be able to resolve whether or not he has it over his eyes, but you could resolve that he has it on his head at least.
Thanks. Is there a way that the RFID can provide an audit of materials such as doors and pipe that have already been installed or not installed, and also can it be integrated with building information models?
Well, one of the things that we're interested in talking to some of the building information modeling folks about that. I know that there's some contracts that have to do with being compensated not for how much materials arrive, but being compensated for how much material has been installed. And so one of the challenges with that is that at the end of the day or the end of the week, a certain number, like let's say the pipe fitter folks come up and say, well, we installed 3,000 pipe spools, and they spot check stuff. They say, okay, we'll go look at this. We'll go look at these 20%, and they'll go out and spot check it. And actually, with that figure that I show with the handheld, and I show piping installed, one of these contracts that we were related to was they wanted to be able to conduct an audit of what's installed. So if you think about it, what I showed there is you can walk through the actual installation area, use the handheld, and essentially reconcile all the materials that you see. Now, you may not get all of it. What's interesting about on metal, which is a classic problem especially for passive RFID, is that it does impede that, but once you have it installed, you have these primary and secondary paths where if you walk around long enough, it's a little bit like a CSI movie, a show, where you walk around long enough with a handheld, you'll see what you expected to see gradually turning gray, and then what doesn't turn gray either didn't get installed or you're having trouble identifying it. So that's all really sounds good, but the thing you have to be careful about is the flash point associated with the labels. So once you start driving your pipes up to a high temperature, you don't want them to create smells and things like that. So you have to be careful about that. Okay.
Thanks, Reg. How about calculating ROI for technology or systems integrating various data? The system should be involved in various processes and related with intangible benefits such as better collaboration, better coordination, etc. How do you quantify these benefits to calculate ROI?
Well, I think the way to do it, and this comes back to that whole productivity improvement plan, which is probably 15 or 20 pages in the book that I wrote. What you really have to do is you have to try to understand what's going on now, like how much time is spent trying to coordinate and facilitate communications. Like, for example, this kind of enters into this probabilistic stuff. A long time ago, gosh, maybe 6 years ago, I did some probabilistic analysis for TSA relating to using passive RFID as a means to avoid lost and delayed baggage. And so I couldn't really talk about systemic inefficiencies, which is common to everything that's going on. There's a certain probability that you can have a bag get lost and delayed, and virtually everyone knows what that is. It turns out that a delayed bag cost the airlines and airports on the order at that time about $200. A lost bag, whole cost, costs over $2,000. So I built a probabilistic model that allows you to essentially load in the attributes associated with your airport and airlines, where you look at the potential for avoidance of delayed and lost bags using RFID and increasing the probability of reading without having to rely on the optical barcode readers. And so I think something along those lines is how you'd have to approach trying to determine the value associated with introducing a means to improve and accelerate the collaboration. I don't know of any better way to do that. So you need to bound the how much is going on. That's a very difficult thing to do, by the way, but you need to try to bound what the inefficiencies are that are fundamentally taking place and where the communication breakdowns manifest themselves in cost, and how frequently does that happen, and how is it overcome, and what are the risks associated. Like if you have something show up and I didn't know this had an ECO and it changed, and why didn't that get coordinated, and things like that. It's doable, but it gets a little bit more difficult to relate to for some people.
Reg, someone wants to know if you can provide them with a list of references where the devices and systems have been successfully executed, or is that something that they could follow up with you directly on?
Yeah, they can follow up with me. This system that I'm just showing you, even though it's 90% leveraging what's already been established, which is what's shown in the slideshow that you'll have, that you can share. It's basically leveraging already established methods and processes in the leading industry suppliers now. So I would say that the best way to determine if it makes sense is to just meet me in Houston, and we can show you the system, and we can talk about what it does, and we can point to the pedigree associated with all the elements and how they come together.
Great. And final question, was the 25% savings theoretically calculated, or was it from real projects? This person says, it seems like a big number. Some non-working time cannot be reduced considering the nature of construction.
Yeah, I've run into that before. One of the things saying, well, if my crew's out looking for schools, are collecting schools or looking for schools, and if they're not, they basically are still on my overhead. And so I showed 25% as opposed to 100%, and essentially in recognition of that. But I would argue that if you're able to use the resources the way effectively, what you can actually do, and the way our system does it is, let's say, so first off, just having them do busy work because they can't find stuff doesn't help anybody. Okay. Secondly, if they have idle time, what we do is actually have a list of materials that we haven't observed, let's say, in some period of time. Let's say I haven't seen this pipe spool any time in the last week and a half, and there's a list of activities that are associated with maintaining confidence that all the material is still in the laydown yard and hasn't been inappropriately consumed. And so you'd hand out saying, I want you to do some background audits of these materials to make sure they're still there. So if you have the resources and they have idle time, you can redirect them to do something that's more productive than just taking their time finding stuff.
Well, thank you very much, Reg. I think we've answered all of the questions. I want to thank everyone for joining us for this hour and remind you that we will have a recording of the presentation, including the audio, posted in the media library at the FIATEC website, which is www.fiatec.org. And a final plug, Reg did mention our conference is coming up March 29th to the 31st, and it will be in Austin, Texas. We've got a full program on our website, so please take a look, consider attending. We've got a lot of sessions, We've got Gentry Lee keynoting the conference Monday afternoon, and a lot of people registered already. So please take a look, plan to join us, and I hope you all have a great week. Thanks.